Hi there, I'm Mark Ubis. Welcome back to another episode of Laboratory of Irreproducible Results. This is episode number 6. I'm going to cover something a little different than my usual video blog. I'm going to cover the reconstruction of an older 3D printer. It's a PrintrBot Simple Metal. So let's get started. So first, a little bit of background on this printer. This is one that my son brought home from his place of employment. It was literally on the trash pile, and it had a number of issues. First of all, the controller board was not working. As an older printer, it didn't have a heated build plate. It turns out the hot end was burned out, completely open circuit. And we found a few mechanical issues along the way, so I can understand why it was on the trash pile. We decided to rebuild it for a couple of reasons. First of all, I've been thinking about building a new printer from scratch, and I thought that rebuilding this printer would be a good stepping stone. Especially, I kind of need to know more about how to build open systems, hardware and software, Marlin-based controller for a 3D printer, and I thought this would be a good opportunity to do that. And second of all, it would be nice just to have another printer in the lab for doing smaller parts. Since I already have a larger printer, I wasn't tempted to make this thing have a larger build volume. It's kind of stock 150 by 150 by 150 millimeters, and I just wanted to kind of leave it at that build volume and get it working in a reliable way. I probably spent the most time on this printer rebuild working on the control unit. So let's start there. This is the controller board from PrintrBot that was originally in the unit. It's I think a Rev F6. It has the usual problem of the surface mount micro USB connector being ripped off. The combination of being surface mounted and small made it just so easy for an accidental tug on the cable to rip that thing off, and they're really hard to replace. You can see where I've tack soldered on this USB connector. I did that so that I could get this board working well enough just to confirm that the motors and drive mechanisms were still working relatively well. But I decided to set this one aside and build a new one from the ground up for experiences, as I mentioned before. And so this is a Arduino Mega with a Ramps 1.4 piggyback, along with the stepper motor drivers, the graphics adapter, and in order to get, first of all, I want to put this part under the chassis of the printer so it didn't have all these wires hanging out. And so I designed and printed this adapter plate, which is on Thingiverse. I'll provide a link in the comments below. But the way it works is it just screws into the original screw points that are in the printer. And then rather than use fasteners to get the Arduino and ramp stack onto that board, I'm using a system of posts and spring-loaded clips. And that's because the screw holes for the Arduino board are just so hard to get to once you've got this thing built up. So the way this works should be pretty straightforward. You basically get one edge of the board and a clip down there. You hold this open and it snaps right in. So that adapter plate is good at holding the ramps and Arduino stack in there. There's plenty of space from a width and a length standpoint, but that Arduino ramp stack is awfully tall. So there's not quite enough room in the PrintrBot chassis to contain that. So I had to do several modifications in order to get that to work. First of all, the original graphics connectors come straight out of that adapter board like this. So I took those off and soldered on these 90-degree versions, so that saved me some space right off the bat. The next thing I did was replace the original fuses. The original fuses go in this position, and they were these poly fuses like this. They stick up really high, and I replaced those with just these glass fuses with pigtail leads on them, and that got things nice and trim there. And I still needed a little bit more space, so I put the printer up on feet. And I found the design for these feet on Thingiverse. I printed them in TPUs, so they're kind of grippy and sound deadening, if you will. I printed these with the original designer's X and width dimensions, but I did double the height in order to get a little more lift on the feet. So those three things together, the 90-degree connectors, the fuses, and the feet, is what allowed me to get this ramps and Arduino stack in there. And then the cables now have a little bit of gap to run out the front of the printer to my LCD display board, and I'm using one from G-Tech. It's a type that's got the selector knob over here flanked with the stop and light PCB buttons there. I was hoping I would just find an enclosure for this on Thingiverse, but the ones that were there were rather poorly executed, so I ended up designing and building my own. If you've watched any of my videos before, you know that I'm a big fan of not needing any fasteners, so I designed an enclosure that simply snaps and holds the LCD together between a front and a back, and there's no separate buttons required to actuate the PCB buttons. The way I did that was just with a cutout here, so you've got a little cantilevered bar with some spring loading on it and a little post on the back to reach down to the level of the PCB button. So the way this works is this simply drops into place there, and then route the cables out the top of the box like that, and then the back has got these toothed clips, and these posts hold everything together, so that just sort of lays in there and snaps together, and it's nice and firm. You've got control of the buttons there, and your selector knob, and of course there's a slot for the SD card right there. So nice and neat, real proud of that. That's the hardware for the control unit. Let me just say a few words about the firmware. I'm using Marlin 1.1.9. It's probably worthy of a whole video blog on its own on how to configure that. I did it sort of the brute force approach. I downloaded a generic copy of 1.1.9 and just went through the config files section by section, configuring it for what was needed by the PrintrBot Simple Metal, and just kind of slogged my way through it. I got a lot of learning done there, and I did find online a couple of places where folks already had some modified Marlin code. I was able to refer to that in a couple of places just to check my work and make sure that I wasn't headed in the wrong direction. Kind of a long learning process, but it was well worth it. I think while we have it flipped over, I want to talk a little bit about the heated build plate. Originally this printer did not have one. I think it may have been an option. I retrofitted in one as part of this rebuild. It's this silicone heat pad right here. It's kind of black on black and hard to see, but here's the 4 wires coming out of it, 2 of it for the heating element and 2 for the embedded thermistor. And I routed those up and around the edge with some spiral wrap, and they connected right into the ramps board and worked the first time. I've been real happy with that. Now, however, without the heating pad, I think the current requirement for this printer was no more than 5 amps, probably more like 3 or something like that. But when you put one of these 100-watt heating pads on here, that ups the power requirements by another 8.3 amps. So I don't know what that, it's probably running somewhere between 10 and 15 amps is the requirement now. And the original coaxial connector that used to be mounted in this spot just doesn't work anymore. These things just aren't designed for that much current. So I'm kind of fond of these Anderson connectors, and so I retrofitted in and redid the DC wiring for this thing using those things. I've got a pair of Anderson connectors mounted alongside the chassis here. I found this shroud on Thingiverse. I'll leave a link in the comments. And there's basically one screw here, one screw hole I had to drill, and this shroud holds these Anderson connectors in place. The wires from the Anderson connectors simply go through the hole that was left when I removed the coaxial jack. And so now I have a nice removable high current connector here. I think I'm using probably 16 gauge wire here, and I did find a inline switch in my junk box. Alright, next up, what did I do about the hot end? This is the original hot end. It's an Ubis hot end. I understand they were pretty much state-of-the-art back in the day, but I noticed that it didn't even have a fan on the cold end of the hot end. So I ended up replacing it with the ever-present E3D V6, which does have a fan. It's not visible, it's back around behind. And now this hot end is a little shorter than the Ubis, which is good because that allowed me to get some additional Z height. I think instead of the stock 150, the way I've got this mounted in here, I now get an additional 10 millimeters. In order to make all this work, let's see, you can't just jam the hot end as far up in the extruder as it will go, because then the Y carriage will actually have some interference back in this area with the base plate screws. So I kind of compromised and came out with a length that worked well for both. So I ended up having to flip around the heater block to the front, otherwise this thing would protrude far enough in the back to interfere with the base of the PrintrBot back there. Let's see, that all worked fine. If you're using PLA, ABS, or stiff filament, you probably don't need to do much more than that. I do like printing this flexible filament, and the void space between the drive wheel up here and the top of the hot end was kind of open. So I found this plug on Thingiverse that fills up that space. I'll leave a link in the comment section. But that did really nicely. I'm printing TPU just fine, without it bunching up anywhere in the filament path. Now the other thing to keep in mind with the shorter hot end, the old fan shroud didn't work. It really blew air too far away from the tip of the nozzle. So I found this shroud for working with a E3D V6 on Thingiverse, and it works. It's got issues. I've tried contacting the developer about it, but haven't heard anything back. But it's got a notch in the design up here for some protrusion on a PrintrBot that my printer doesn't have, so I ended up just leaving the support material in and epoxying it in place. There's a hole designed into the back for some reason. I plugged that up with some epoxy, and it's very finicky about what length screws you use here. I think I ended up having to use exactly 1-inch screws in order to make all that work. So it's not a real refined design, but it works okay for me. Okay, so as I've referred to earlier, there were a few mechanical issues with this printer. One minor thing, for example, was the grub screw was loose on the coupler, or on the pulley for the Y motor to the Y belt. That was an easy fix. I'll talk about that a little bit more in a minute. The other thing was the grub screw for the coupler on the Z threaded rod down here was stripped. And I originally replaced that old coupler with one of these spiral, I don't know, I call them a spiral ham, but they're I do not recommend that. You'll see here in a minute that this resulted in a lot of Z-banding. The theory about connecting a threaded rod and a stepper motor is pretty much you want them as parallel as possible and as centered as possible. In practice, that's impossible to get exactly right, but you want some coupling mechanism between the two that allows for a little bit of X and Y motion, but you don't want any up and down play in that mechanism. And of course, with this spiral cut kind of thing, there was a lot of play there, and I'll talk more about that in a minute. I recommend these couplers with the elastomeric core. It works a lot better. The place I spent most of my time mechanically was on the linear bearings inside these blocks. There's actually two of them. So this whole carriage here slides up and down on these rods. There's two of these linear bearings in each side, one up here, one down here. It turns out one of these things was really rough. I tried cleaning and re-lubing a few times, but just could not get it to work right. And so I spent half a day trying to figure out how to get these linear bearings out of these blocks. It's really tough. So because there's one up here and one down here, it's what's called a blind a blind arrangement. You can't easily get to the back side of a linear bearing to push it out when you've got the other bearing in the way. I finally hit on the idea of just doing a destructive removal by using a screwdriver and needle nose pliers to get the plastic liner and all the bearings out from one side. That gave me enough room to get a tool down in there to just pound out the other one, and then I could flip over the block and drive out the other one. I did that for both of these things. Fortunately, getting the new ones in was a lot easier. I used the trick of putting the blocks in a toaster oven, putting my new bearings in the freezer, and then when I pulled them out, the bearings slipped into the blocks pretty easily with just a minor amount of tapping. Let's see, I also replaced the Y carriage radial bearings while I had everything apart. I don't think the originals really needed it though. But my lesson learned here is that I'm really going to avoid situations where you have blind bearings like this. They do make tools for removing bearings that have no access from the back, but they're typically for radial bearings, and the tool only has about this much reach, and they don't work at all for these linear bearings. So lesson learned there. Alright, so we made all those updates and modifications to the printer, fired it up, and it printed fine the first time, right? No. Well, there's always a little bit of debugging there. So here is the first test cube that we printed after making all the mods. A little bit rough, as you can see. On the Y face here, you'll see a lot of layer shifting. I hope that comes out all right. A lot of layer shifting, but only in the Y direction. And I traced this down to that loose grub screw on the Y motor pulley. So that was a pretty simple fix. Another issue, you'll see this glob here. That's because there was a leak in the hot end. I didn't get it tightened up well enough on the first attempt. And then another issue that's not so obvious right off the bat is that Z is printed backwards. You can see that. So that that was because the Z-axis was printing in a mirrored image. And to kind of demonstrate what's going on there is the Z, or the Y-axis limit switch is back here. You can hear it click. So my initial thinking was, okay, we'll just call that the origin, and mentally assume this is the plus Y direction and that's the plus X direction. But I didn't really think through all the ramifications that resulted in this being printed mirrored image. So I went back into Marlin and I redid it the way I think PrintrBot initially intended, and that is to define this limit switch as the maximum limit switch. And by virtue of telling it I've got a Y print dimension of 150 something millimeters, and told it to reverse the direction, reverse the action of this axis. So now this is considered the origin, even though on a homing operation Marlin is pulling the head back to here to find where the limit switch is. So anyway, those were all fixed, and then I did another print of the test cube, and it came out looking a lot nicer, but you'll notice all of those bands, those horizontal bands, and those aren't just layer shifts, random layer shifts. That's a few layers, too far this way, a few layers too far that way, and you'll notice it's not limited to just the X or the Y axis, and that's what led me to the problem with the coupling between the Z stepper motor and the threaded rod that I was talking about earlier. The other clue here is if you look at the frequency of that banding, that corresponds exactly to the thread pitch on the Z rod. So I went in, made the changes to that Z coupler using the elastomer core, and did some more aligning, and came up with this is probably my most current printer cube, test cube, and it's looking pretty nice. Still a little bit of banding in there. I could probably tune that up a little better. And I didn't talk about it earlier, but the corners are now attached a little bit better to the build plate. So pretty happy with that. Alright, just wanted to wrap up this video. I feel like I certainly got what I set out to do, which was getting an education in Marlin and building a 3D printer controller via open source parts. And I got this great little printer in the process. This is sort of a meaty project, and I know I've netted it down to a fairly short video, and so if you've got any questions about details or questions that I just didn't cover in the video, or if you've got suggestions about things I should have done differently, I'd love to hear from you either way in the comments, so please feel free to post. Until then, keep on making and have a great day.